start. Check, 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 check. Sound is on.
Yes.
There we go. Okay, so we're still working on vectors. We're going to operate on vectors today. Today we're going to do something called a dot product. A dot product. So we're going to be doing dot products. I'll show you a couple different things between those. And then we're going to talk, this kind of blew my mind a little bit. We're going to use the dot product to determine if two vectors are orthogonal. I'm not sure if I'm saying that right. It sounds like kind of chiropractic type stuff. Orthogonal. Orthogonal sounds better. But I'm thinking like orthopedic, you know? Orthogonal sounds, it's just a little better, but it's like, what? Then if we have time, I don't want to like over push it either. I know we have tomorrow a little bit of time. We can do some review today, tomorrow, whatever it has to be. Do the other ones where we're doing projections of one vector onto another, and then express them as two orthogonal vectors. Okay? So, I didn't finish that, my bad. Okay. In a previous section, we did learn that operations of vectors, you can sit over here on those sides. A vector scalar multiplication results in vectors. The dot product of two vectors results in a scalar. It's actually a real number, so you're going to get just one number. And it's actually a pretty simple concept. So, everyone okay with the dot product? Yeah. You're going to be multiplying two vectors, and it's going to produce for you some scalar. Okay, it's just some integer, if you will, real number. Okay? Make sure I got my notes up now. Can we do it first and then I give you the formula? Because sometimes we look at the formula and we go, I'm tapping out right now, and it looks hard.
If you say it's hard, then you should put the right now and then I'll watch you.
How about I go back to it? Would that be okay? Oh, you know what? Okay, here you go. I'm alright. It was next in order anyway, so here it goes. So if you have vector v in the form of a sub 1 times I plus b sub 1j, and you got vector w, then you're really just the dot product would be the product of the coefficients of such. So a1 times a2 plus the product of b1 times b2. And that's it. Okay, so don't let that psych you out or get crazy. It's not hard at all. Multiply plus the product. Product plus the product. I got product of the A's plus the product of the B's. That's all it is.
Oh, okay.
You see? Ah, yes, exactly. Oh, that's all it
Wait, so
is.
is it like when you multiply like I squared equals negative 1 and like kind of like that but not like that?
It's exactly the same but different.
I appreciate that. Because in my mind it makes sense, but
I can see how that can make sense in your head. If that makes sense in your head, then cool. And then right now you'll be able to confirm it once we do an example. So if the product. Test. Quiz. Test.
Our test is on Tuesday?
Yes.
Tomorrow.
No, it's not.
I can't do Tuesday.
I'm guessing it's
Then
Tuesday.
it's next Friday.
Thursday. I can't do Tuesday.
See how easy we solve this problem? Is there anything? I love it.
So is it not?
No, it's still the same. I just want to. I just like. I'm sorry. That's just me. I'm a jerk. I like making people
You
stress.
know, when you
I apologize.
joke around like that, my heart
Forgiveness, please.
heart goes like this.
Remember that
My blood
one
pressure
time?
goes like this.
Hey, did you three sign up to go do the march?
Yes. What March?
The senior march.
What senior?
Look in Blackboard.
Is it
Please,
senior
you guys
march?
drive, right?
Yeah.
What day is it?
When you do graduation practice,
Okay.
right after.
What day? First day or second
The
day?
first day. No, not the
The
second
second
day.
day is
First
graduation.
Yeah,
Yeah.
the second day.
Nobody's gonna do anything on the day of graduation.
So Monday.
Monday.
Okay.
So after graduation practice, you drive down to an elementary school, and then we're gonna do a senior march for the kids. We're trying to start that off. Be like, high five, guys. This is you. And
We were,
Okay.
okay.
So is it on Blackboard?
yeah, please sign up. We need people to do that. Sign up. You're not a senior. Next year you do it.
Where?
Wait a minute, are you junior?
Yeah.
Yeah, so next year you do it.
What school is it?
Saguaro/CGNS.
Oh, okay.
And we wore our gowns.
Yeah, you bring your gowns and you're gonna do this big old.
Oh.
Look, we're done.
And no, we're not really done.
That's the hard part.
Technically, you will be.
technically we won't be. None
Why?
of us. We're going to college.
Well, you're done with high school.
Yeah,
This is the easy
like that
part.
makes a difference.
It does. Pop in circumstance, right? It motivates kids.
I'm
Alright.
like, I think we need to do this
After
more.
this year, I never have to play that song again. After,
Are you dropping band?
no, I will have to play because I'll be a senior next year.
Oh. Ah, touche. I see what you're saying.
No.
Alright.
I wish I could rip it.
So, dot multiplication. We're trying to find the product of the vector v and vector w. So we're going to take the two a's, which is 7 and 2, add to that the product of the other two. That should give us, what, 14 minus 4? Yeah?
Sure. Yeah, buddy.
You try the next two.
Wait.
Wait, W times W.
Wait a minute. That's not right. What mistake did I make? Where's my mistake?
You put plus.
Minus
It's
or
plus.
minus.
Negative, negative makes a positive.
Oh.
So it should be,
18. Buddy boy.
try the next two, please. Try the next two.
Okay, give me a moment.
Why? That's on you. The notes you take are for you, not for me. Right?
My hair is like,
I shred like a dog.
You okay?
yeah, my hair is like,
Yes, it's pretty long. My hair's everywhere too.
so gross. Like, I see a little strand, I'm like,
Your own hair? It's your hair. I used to, but not no more. Not if it's my hair, or my wife, or my kids, we're good.
It's a hair.
like I get so scared when I'm home. Even though we have our hair in our bands, but like my baby hairs, they sometimes like stick out of my hat. I just get so scared. I'm like,
Wait, this is Munoz.
What's up?
property.
That was a fist bump and some loading. That was my vector bump. What's up?
Where is it at?
Saguaro.
No, I mean like in the actual.
It's down for now.
Oh, I know where the I went.
Oh, my bad.
I meant the sign.
Look for the one from the counselors. Don't they have something for the counselors? Yeah.
Community resource.
Check your email.
Oh no, I don't.
I think I got something like that.
Jay-Z song is on. Oh, someone get that song in my head.
What song?
Oh, wait, what song?
The Party in the USA. All day has been like a Mesa.
Party in the USA?
Miss Munoz, I have a remedy for that. If you ever get a song stuck in your head, sing the end of the song and watch what happens.
That doesn't work.
I just sing more.
I don't know the end of the song.
Dun, dun.
Create the end to the song and it trains your brain to stop thinking and continue.
Okay, so can we just sign up? Can I just sign up with you? Because it says, you can see one of us, or Mr. Munoz for more information. You just take my word for it, I'm gonna be
I'll
it.
put you on the list.
Okay.
Can you put me on the list too?
For show. Show.
I want to
I
make
love
sure.
how you're switching it. Like,
Well, because it's already switched, so I didn't open it through. So I'm just putting it up.
Wait, what?
do you know how to make candy? So you might have to make a face inside of candy. And it's face like make it like this.
Please confirm your solutions. We're good? For this one? This one's just 5. Right, because it's the same vector type of stuff. Okay?
Oh no, I
So
added
14 plus 4 got 20.
Can't get my knee
Did you
under
see
the
my message in the chat?
It used to be 20, but then they changed it because the math was.
Thank you.
Thank you. you.
Nate.
So you were technically right. Alright, thank you. Do you guys recognize these?
Yes, I do.
Yeah.
I
Good.
wrote them down yesterday, I think.
It's a new set, but it's okay. But they work the same, technically, yeah.
Write them down.
It's still the same old commutative, associative, the product of zero. This one's might be different for you, right? This one's the associative for addition, this one's associative for multiplication. But if you take a vector times a vector, then the magnitude will simply be squared, right?
Yeah.
Vector times a vector, you're going to get magnitude squared. So if you don't sit there and do that, just find one magnitude, square it.
Miss Moon, is there a water fountain by the bathroom?
Yeah.
When you reminded me of when I was in junior high, there was this big myth that because there's always a water fountain by the bathroom.
What?
No. That was kind of true when I went to either. But anyways, everyone would say that the water was just straight like from the flush when they flushed it. It would power the thing. So I never drank out of those that were connected to the bathroom. I know.
That's why I don't drink water.
When I went to college, when I went to CEC, every water fountain had a warning. Pretty much, drink at your own risk. Yeah, swear to God, and because it was so bad, you would press on it, and the water came out so dirty, it looked like milk.
Why would they even have this? Like the water was like metal.
It had a lot of garbage in it, yeah. But there was literally like signs in every water fountain had like drink at
Does
your own
our
risk.
water do that?
So I just drank soda.
Oh, I don't.
Is
Go
our
back.
water dirty?
Go back.
Yeah, get in that last
Miss
part.
Munoz,
What's up?
our water dirty?
No.
I drink bottled water. We go down, we drive down the big old 5-gallon jugs, and we fill those up. We don't drink out of the tap.
I'm like, how about we all go test it right now?
Oh,
Like if it was an emergency, I would drink it because I don't want to die. But
People drink tap water in Arizona?
Yes.
Well, yeah.
Well,
My
they
cousin
don't
from
want
here from Alabama, they tried to drink
I had some students that they drink out of their horse tap.
We're good one.
All right. Thank you. I've got an alternative for you on the dot product. Thanks, that works.
If you're
Quiet spread. Alternative on the dot product using cosine. So if we want to find the product of V and W, we can take the.
Can I go take this?
Wait, I need to write down the if.
Like, honestly, that's
Oh, I see what you're saying. Can I control Z that?
again.
There you go. I feel like you can't read this though. Is it visible back there? Okay. Maybe it's because I'm blind. I think everybody else is. Oh, Johnson's got glasses. She's going like this.
I really can't.
What up here?
I can't, you can't see.
Wait,
Where's Dallas?
Are you?
Oh, there you are.
You're a sophomore?
It's right there. That vending machine right there works.
Dude, I
Just went
thought
through your
that
water.
was a junior when I sat next to her last year in class. I was like,
Get your supply before you come here. She does this now. I put myself down. She goes,
I want to leave school. I don't want to leave my job.
You see that's the thing. Oh, that's what it up again.
The next day, that we get out the day after we get out of school.
Oh, that was great though. I like that. I feel nice again, man. I was so thirsty today. It was crazy. I just didn't want to run out. We're good? No, we're not good.
Can I? That's the magnitude, right?
Yes, that is the magnitude.
It's that new shrimp thing, but
So that's if we're dealing with like angles and stuff.
Yeah. If you have the cosine, you could do that.
I'd like 3 samples of that.
I know that was like a little bit. think it's funny when they're like.
I just drew two vectors up there. If you want to find the angle between the two vectors, the smaller of the two. So what I'm about to give you would give you this angle, not the major one, the minor. Looks like that.
Wait, can you go back
To what?
for that?
Well, we're not done with this one?
Wait, the big one is the next one.
To find the angle is the next one.
Yeah.
This is just an alternate on that. On the
first
dot product.
I need to write.
I can do it on the other side. On the side it's supposed to be.
So then the next one's the big one.
Yeah, the next one is the angle one. Okay, here you go.
I need some.
What did your group do?
Change the hoses and cut off some.
We were working on it.
Bye, Micah.
The hillbilly smiley face. Where it's like this.
That looks cool. That looks cool. No, leave it the way it
He
was.
took off
It looks cool.
his drive shaft.
I like
on the Pontiac. He took the drive shaft off. Then there's the table in the back.
What exhaust?
Why didn't they just take it off of the
They took electric saw and saw.
Is that what they're told us to do? Is that what they told them to do? So then why they just take it off with the ratchet? It's not that hard. Huh? With the welding?
Put it in the morning and take it out.
Wait, isn't that the one with the little kid and
Sounds like we're done here, so.
Yeah.
My God, buddy, what's up? Really fast.
I'm gonna flip the classroom. I'm gonna flip the classroom.
How are you gonna do that?
No, do you guys know what a flip classroom is?
No.
Like, I actually teach everything. I put it on YouTube. You watch it, and you come back with questions, and I answer them in class, and then that's all we do all the time.
I can do that.
No.
See, I don't have enough
I like that.
time.
Exactly. I go home and do that.
Actually,
That's
I
what
found out that
classes
it said,
are.
oh,
I prefer to go live first interview.
Now let me tell you, if I get a college professor
That's what
like
you're
that,
after.
I'm dropping out.
There's a lot.
That's all it would give you. It won't give you the major angle. So if you want the major, we'll have to find the minor, and then subtract that from 360.
Oh, what?
Right? What are you talking about? What is it? This formula will give you theta. That's the minor angle. If you want the major angle,
I don't think they can get my back.
okay. Got vector V, and I've got vector W. Okay, and I want to find the smaller of the two. I can do that with that formula we just got. I believe the formula for V times W is V times W, right? Or sorry, to find the angle. No, this shouldn't be that. It should be what? Theta? Cosine theta is V times W over the magnitude of V times the magnitude of W. Someone correct me if the formula's wrong.
It's wrong.
What did I miss?
No, I think you're right.
I am missing the line, aren't I?
Yeah, you're missing
Thanks. Okay. Oh. You guys ready?
There's a timer letting us know we have 20 minutes left to class.
No, I was just exercising.
No, we don't have 20 minutes left.
I can't hear you. Ah! You insult me. Cosine theta. This is cosine theta. That's a little bit better?
Yeah.
Cosine theta. So everyone okay with what we're after? We're after theta right here. Right here. What is that?
4i minus 6.
What is that? 4 minus 6?
Yeah.
Did I do that right?
No, but like trying to close.
Or
Are we gonna
So-
go over the homework tomorrow?
We can.
I didn't finish the second one, but I had a question on it.
Is that right, Ernie?
yeah.
Welcome back. So we're after theta right now. I got my two vectors up on the wall. Gallus, vectors on the wall, I mean on the upper right hand corner. We're after that angle theta, the smaller of the two. So for the top, I just use my dot multiplication. Now I need the two magnitudes, don't I? So how do we find those magnitudes? Pythagorean theorem, or the distance formula. So we've got, where did it go? Let's go with V first. So I've got 4 squared plus negative 3 squared, and then we take the square root of that, right?
Yeah.
So what is this? 16 plus 9, is that 25?
Yeah.
So I got square root of 25
Yeah.
times the square root of 5? Square root of 5?
Yeah.
Yeah.
So this is going to be square root of 125?
Yeah. Which is
Which is what? 5 radical 5, right?
yeah.
So it's just 5 radical 5. So I've got that. I can't have that here, so I'm going to multiply like this. So we've got negative 2 radical 5 over 10, which becomes negative 5. Sorry.
Wait, isn't it over 20?
How is it
Over
over
25.
10?
Yeah. Should it be over 25?
5
Because
times
5
5.
times 5?
JK.
Oh, you just did it a little far.
It's radical less than.
JK, smiley face, hello. There we go. We're done.
I should have recorded you, JK, smiley face, hello, my entire high school
Okay.
career.
Now, here's the deal, though. Is this an angle? Is that the angle? No, that's what cosine of theta is equal to. How do we get the angle? We're going to use the inverse. So we're going to ask our calculators, hey, calculator, give me the cosine inverse on negative 2 radical 5 over 25. Someone find me the angle, please. You guys are trained for this.
I got. Oh, hold on. Okay, yeah, no, I got
We're going to
96.
lose you.
I got 96.49.
What is 96?
I got 100.3.
Okay.
Okay?
Maybe I can make it.
Is that negative 2 radical 5?
Yeah.
Over 25?
Yeah.
I got it.
Now, thank you.
Degree mark?
Just a heads up, since I'm going to use my calculator anyway, I didn't have to go through all this process. I could have thrown this in there. I could have said cosine inverse, negative 2 over 5 radical 5. It can handle it. Okay? But I'm pretty sure that MATLAB will ask you for this at some point, and then you have to be able to spit out the angle, correct?
Accidentally.
So that's why we just kind of did that at the same
It was
time.
100 point.
How many?
It's 100.3.
Holy smokes. 100.3 degrees?
Yeah.
Thank you.
That is absolutely correct. Okay, you guys ready? Someone still writing?
Okay.
Okay, Ernie, that sounds good.
Rockefeller stuff.
I like that. That's cool.
See, we can't do that. All we can do is like whip our hair maybe if it's long enough. Roll my must off.
See, I can't do that.
I like it.
Cool. Are we good? Okay. Thank you. I'm gonna try to use that too. The next slide, I have an issue with a little bit because it uses the word parallel in a way that I've never seen it used before. The math that I know has been a lie all my life. What do we call parallel? What is parallel, guys? Two lines, same slopes, right?
Yeah.
But,
They never intersect.
and that's the problem that I have with this next slide. Remember we talked about orthogonal?
Yeah.
Okay, two, it's on. So two vectors are considered orthogonal if the angle between them is 0 or 180. Now, you see why I have an issue with this? When I look at the images, are they really what we would call parallel? They have the same slopes, but I would call these coinciding.
Yeah.
But we're in the vector world, so these are called orthogonal. Notice that this one, there are two rays headed in the same direction.
Yeah.
Therefore, the angle would be 0. Here we have them going in opposite
Should
directions.
be 180, right?
Therefore, this one would have 180.
Okay.
But regardless, if they have 0 degrees between them or 180 degrees between them, that makes them orthogonal.
So then if they were like this, would that
Okay.
be 90?
I think there's another name for that.
But it's not really intersecting, it's just like,
No, but
No, they're coinciding lines. They're the
Yeah.
same line, but again, we're not working with lines, we're working with
vectors.
vectors.
Okay, okay, okay. I'm gonna write that down.
That's what I'm saying.
Oh, I gotta get this done. My start date is-
So what do we call these type of vectors? No, not orthogonal. We call them,
Parallel.
two vectors are parallel if they're 0 or 180. I want to make sure we're clear there, Ms. Campbell. 0 and 180, what type of vectors are they? Parallel. What makes them orthogonal? You guys ready? No, not 0.
No.
I'm ready.
I have to write down the word.
Cool. Okay, let's be clear. This is your condition for parallels. Don't do it, Cotton. Don't do it. Oh, that looks even cooler. To the front. Got a little Elvis thing going on.
It's just falling apart right here. Oh, like the ones with the horns? Yeah, yeah. I feel like a unicorn looks better.
no, not a Yeah.
Yes, they have the big heads. What are they called? What are they called?
You look like a cheerleader, like I'm gonna charge it 3 years ago. Like everyone did the little hoops. That's what like
Dance
the
I mean, like, isn't how the screen you do?
Do you wanna see it?
You know what? I look like one of those like
You?
whales.
All the
Some
rules.
sort of a bird.
Wait, who was supposed to choose one?
Oh, no, I'm
Or it's like the bird up
it's your
has
friend.
like a really big feather.
Your friend, any like, I don't know.
Yeah.
Condition for orthogonal. They're gonna come up at like right angles.
Oh.
So we don't call them right angles, we call them orthogonal. Orthogonal. Orthogonal.
Orthogonal. I was gonna say something.
Orthogonal.
When is the 90 degree and the
So we're working with vectors and not lines.
So you gotta write it.
These are fancy lines. Well, remember, a vector has some force implied on it, doesn't it?
These are fancy.
So once you have a vector with magnitude, then we're talking about this. Well, if you think about force, you're just applying a force. And so if you hit something at a certain direction and strength, that's your vector. So technically, a ship that's in motion has direction and it has a force. I guess the vector is magnitude. Okay, so if you can visualize things in motion, I think the vector. You can see it a lot in buildings. You use that a lot. They're not things that you got but they are. I can show you
So I just sat down with her. I was on the you just look up. Yeah, you just look up. There you go. You just look like you're just looking up.
A lot of, yeah. Well, you see, we took out this drive shaft. We actually realized it. We were gonna start taking the box.
Okay. Silencio. Now let's apply this. Are the vectors v and w orthogonal?
Let us find out.
Yes, that's what I was going to do. Go for it.
Yes. Yes.
Use the one thing, right?
The dot product.
The one where like cosine theta and theta?
I feel like you're dragging.
A times b, or a times a plus a times b.
That's it. You just plug this in. That's it.
It's a right.
How do you know it's a right angle?
Because it's orthogonal.
How do you know? That was the question.
Oh, well, that's what the.
Tell me.
I'm telling her what orthogonal is.
Oh, if it has 90 degrees between them?
Wait, can't you grasp it? Like that?
You should be able to. Let me see. So, 1, 2, 1, 2, 3.
Yes. You like it? I did it for you.
So what I could think about is, Tara, you asked me this question. Pay
I know,
attention.
I'm paying attention.
Okay, so the way I could think about it is I can use the ideas of slopes, and if they are perpendicular, which it would have to be, correct? That means that their slopes should be opposite and reciprocal. So here I'm going up 3 and to the right 2. That means that this slope should be a negative 2/3, correct? So let's see here. I went down how many? 4, and I went to the right 6. So yes, that still works. Yeah.
Is there a mathematical way to do it? I got 0.
So 2 times 6 plus 3 times negative 4, 12 minus 12 is equal to 0, correct? So what does that mean? Is it orthogonal?
Yes.
I didn't look at 5.
No.
The product is 0.
Yeah, but what does that
So is it
mean?
orthogonal or not?
What is it saying?
It would just go forward. No, it's
I can only hear 3 people at the same time.
Ow, ow. You said.
One. Go ahead.
You said that if it's 0, then they're moving in the same direction, yeah?
No.
That makes them parallel.
Makes them parallel.
So that means that they're not.
Orthogonal.
The angle between them has to be 90. Go ahead.
What's 0?
The dot product.
Yeah, but what is 0 representing?
Here, let's go to here real quick. Up.
Actually, it's Kika.
Here we go.
Is 0 like an angle or a degree?
You guys remember that?
It's your cosine.
What makes them orthogonal? Okay.
The vector is 90.
Here's your hint. Right here. When the angle is theta, what's the value of the cosine? Does that make sense to you? That should make sense to you. Look at my if I'm over here at 0 or 180, then the cosine technically is how much? 1. What is my cosine when the value is 0?
0. Oh.
When the cosine is 0, where am I at? 90 degrees. So am I orthogonal? Am I orthogonal? Yes.
Oh.
Okay, wait.
Oh, yes. Yes, we are.
All right.
Yeah.
Your hair is so tight.
Okay, get this formulas down. This is a projection of V onto W. Projecting vector V onto vector W.
What does that mean?
Where's the math?
What does that mean?
I'm not sure what this means. Let's see here.
Projection.
Did it show you W? Cross
I
Y?
love it.
No, all Russia look like from the Princess
Room and everything.
So it looks like
I wish I was from
No.
I bet you they don't have high school Venus.
No, but like
This one?
or what if
Oh.
One.
All of you.
Oh, shiznits. Can we pass this? Oh. What the heck? That is a big one.
Never felt uglier in my life.
One.
You kind of look like Cindy Lou from.
Half a big
Oh
one.
my god, did you just say that going down your hair looking like that? I have.
If you ever give me one, I'll put my mouth for half it.
So we're doing
One.
Or I will do it in the future. What is this?
That was the little dude. The muffler
Which
fell
one should I
off of me.
leave it in the bun or the other?
That's the
Or
muffler.
do another bun? So should I make this
No,
into a
it was
bun?
nothing ran through here.
Okay, ready?
Great.
He's still trying to figure it out. You literally got one wrong. Let's look at that. Hey, you literally got one wrong.
Which one did you get wrong?
He was just barely holding
What
it.
number was it?
How do I do that?
She's like 5 a little bit.
He's
On my wall.
yeah, like he just went.
I don't know how to
It
do
was
that.
light. Somehow you said it.
I'm like,
I just said it. Yeah, it just yeah.
I feel like you're a very doctor by
Yeah, I did actually. That's like
I got it.
do a full okay. Here, let me.
I feel like this is what Pinterest moms try to do.
Take this back.
The whole thing was like this. There's a
You know, I actually the mobility.
All right, I'm going to end this. We're going to stop there, and then we're going to